Hello, and thank you for joining Getting Started with Identity on AWS. I'm Mark Shalkevich, a Senior Identity Specialist with Amazon Web Services. For many companies, it wasn't that long ago when security was mainly defined by the corporate firewall. Identity was primarily focused on employees. Resources were a relatively small number of things, primarily within your office or your on-premises data center. Compliance was much simpler. It focused on things like password strength for your employees. Administration was based on centralized security and ops teams, and cloud was something that hampered your suntan or was just up in the sky. And along came the disruptors. Mobile, consumerization of IT, globalization, IoT, new privacy laws, microservices, SaaS applications, the cloud. And today, this is where the industry is heading. Not everyone is getting there at the same pace. This may vary by company and by industry, but today security is about a zero trust architecture. Trust nothing, authenticate everything. Identity now includes employees, partners, contractors, applications, microservices, resources. There are so many more. It's global. In AWS, customers are even managing access to robots and to satellites. And compliance is not just for employee passwords anymore. It's focused on end customer data privacy, GDPR, CCPA. Administration has become decentralized DevSecOps. We want to empower our developers without ceding control. And cloud, it's now common to talk to customers who have many cloud accounts and SaaS applications. So now that we've discussed where identity was and where it is today, let's discuss ways on how to scale during an identity journey. Along the way, we can highlight the various models such as AWS IAM, Federation, and AWS SSO. So in terms of the identity premise, this is on who has access or who can access what. So looking at identity and access resource management, the who consists of the name, the credentials, the metadata, and governance. The can access is about the policies, the compliance, the governance, and the what is about isolation, grouping, tagging, sharing, governance. And so governance goes across all these. So, for example, governance could determine if someone can connect an external IDP to their identity, or have some level of guardrails around how resource sharing works, or perhaps to gather and present information on who can access what. And so each of these fall into an identity, access, resource management pillars, while the who has standards that exist that help us with identity, like SAML and OIDC. Access and resource management need to come together in an environment-specific way to get the full richness of that environment. So if we provide another view of the slide, we can see that identity comes into the central policy point. Alongside it, there's metadata about the resources that come into a policy, into the policy point. A policy administrator pushes in policy information. The engine works on these and provides permissions to grant or deny access to something. This can be simply accessing an application, or it can be more complex, such as giving resource-specific, fine-grained permissions, such as allowing to start or stop a service or launch or shut down an EC2 instance. So let's dive into AWS Identity, and we'll talk about IAM, Federation, Directory Service, and AWS Single Sign-On. So we began to scale identity management by working backwards from our customers' needs. From large enterprises wanting to use enterprise identities they already have, and to make it easier to manage access at scale across AWS accounts, to startups and smaller companies that prefer to have identities usable inside and outside of AWS, to simplify multi-account permission and to simplify multi-account permission management. When AWS first began, we created a model for signing in and controlling access to resources. We launched AWS Identity and Access Management, known as AWS IAM. It's a management framework which included a database in which to create users and groups. This framework included the notion of an account, which was a billing container, and an isolation boundary in which customers created resources. By default, it was an isolated tenant, shared nothing, trust nothing. So administrative tasks and user logons were per account. It enabled you to create principals such as users with fine-grained permissions, and enabled customers to move to the cloud with fine-grained access controls. As customers grew with AWS, they began taking advantage of AWS isolation boundaries more and more, and they began creating more and more accounts. This enabled them to empower their business units to build in the cloud without affecting other business units, and to separate out the cloud resource expenses for each business unit. But as customer adoption grew, so did the need to manage users at scale, rather than in each and every account. It became clear that we needed something more to help customers manage access for their users across all of these AWS accounts. So AWS created the concept of a role, which is a virtual construct intended to mimic a job role, such as a database administrator. Rather than assigning permissions to users or groups, permissions are assigned to a role, and then you assign users or groups access to that role. This construct allowed customers to create a relatively small number of roles, and then assign user permissions to assume roles based upon their business need. When a user assumes a role, they have permissions to only those resources granted to them by the assumed role. As people changed jobs, it was easy to move them from one role, assign them into another role. But the admin had the task to create user identities in each AWS account, and also to create the groups and the group membership. They had to create the roles, attach the policies to the roles, and assign the roles to groups and users, and that's how everything came in. So customers had to create multiple identities for their users because, again, IAM users are per AWS account. And this became cumbersome to keep the users and their credentials consistent. From an end user perspective, I would have to sign into the right account using the right credentials that are in a particular account or in that particular account. If the admin or admins were not consistent with each account, I may have a different username. I may be marked as Z in one. I may be marked as ZA in another account. And so I also had to recall the name used, and I had to also be worried about managing the passwords per account. And then when I got in, I had to actually assume a role. So this worked well for many years, but as companies began to scale up and cloud use increased, there were more and more accounts. And this became much more complex. As well, it was becoming a barrier to manage user identities in AWS separate from identities customers were using in their own on-premises networks. And so we needed a better way to do this. But as mentioned earlier, customers wanted to use their identity providers with AWS and sign in with identities they managed in LDAP or in Active Directory. In response to that, we worked on ways to create trust using federation, and we added IAM federation. This enabled customers to federate into each one of their accounts with an IDP of their choice, such as Okta or Ping. You would create a trust with the account, but the admin still had to create the roles in each account, attach the policies, make the assignments, get the manifest out from the IDP, and make sure that the users matched up as well. There was a lot of work still involved with this. This gave customers the choice of using IAM identities or using identities of their IDP. It also started a shift from using permissions assigned to users and groups to using roles as the primary method for granting access. So I want to take a slight pause for a quick refresher and talk about role-based access control. This has been available in the industry for quite some time, and in AWS, it is the traditional authorization model used in IAM. ABAC defines permissions based on a person's job function. In AWS, you implement ABAC by creating different policies, shown in the center, for different job functions. You then attach the policy to an identity, which is shown on the left. It could be a user or a group of users, IAM roles. And this worked well until the number of user types and roles inherently increased, which provided a disadvantage to this traditional ABAC model. When a new resource was added, you had to update the policy and to allow for access to those resources. It became difficult to manage as many users had to access many types of resources, and policies quickly became out of date, and they really needed to be updated. Now, let's go back to federation. From an end user standpoint, life got easier. As you can see in item 1, the user can go to a familiar place to sign in. We happen to be showing an Azure AD login screen, but it could be Okta, it could be Ping. And once signed in, the SAML assertion sends metadata about the user into the AWS console, where the user can be identified to have those permissions in those accounts, in those roles. And as in item 2, you can see the user can choose which account to use and which role to go in as. This is still easier for the end user, but the admin still had an awful lot of work to do here. So with Federation, you can use single sign-on to access your AWS accounts using your corporate directory credentials. Federation uses open standards such as SAML, Security Assertion Markup Language 2.0, and this exchanges identity and security information between an identity provider and an application. AWS offers multiple options for federating your identities to manage access to your AWS accounts and resources centrally. You can use IAM to enable users to sign into the AWS accounts with existing corporate credentials. And you can also, AWS also offers non-SAML-based options for managing access to your AWS resources. AWS Directory Services for Microsoft Active Directory, also known as AWS Managed Microsoft AD, uses secure Windows Trust to enable users to sign into the AWS Management Console, to AWS Command Line Interface, and Windows applications running on AWS using Microsoft Active Directory credentials. Although not covered in this presentation, you can also add federation support to your own web and mobile applications using Amazon Cognito. To help you scale up as you add more AWS accounts, you can use AWS Single Sign-On to manage SSO access to multiple AWS accounts and business applications centrally, which we're actually headed to right now. So the next step was to deliver an AWS experience for AWS account access, as well as access to cloud business and to AWS applications. However, we first needed to get the accounts governed. So we did a few things. First, a few years ago, we created the AWS organizations model. Taking an idea of all this big list of accounts and let you create a structured organization around it by grouping accounts into organizational units. So AWS Organizations does more than just centrally govern and manage identities and permissions across accounts. You can manage and define your organization and accounts. You can control access to permission. You can audit, monitor, and secure your environment for compliance, share resources across accounts, and centrally manage costs and billing. It powers AWS Control Tower and AWS Landing Zone, and as a reminder, both are used to create a foundational AWS environment based on best practice blueprints. Now, AWS Control Tower provides the easiest self-service way to set up and govern a new, secure, multi-account AWS environment based on these best practices and predefined set of blueprints and guardrails, and this will help implement the landing zone for new AWS accounts. AWS Landing Zone provides a fully configurable customer-managed landing zone implementation. You have rich customization options with custom add-ons, for example, Active Directory or Okta Directory, and ongoing modifications through a code deployment and configuration pipeline. So, AWS Organizations enables you to organize accounts and manage their relationships, organized in a way familiar to you. The ovals represent the organizational units. And what you can do is actually set governance policies that would flow down through that organization. And it's set up guardrails for what users can and cannot access within the environment. That is to stay within these boundaries. So now we have a hierarchy for governance policies and being able to provide a framework for cross-account sharing of resources. So now, in addition to organizations, in about late 2017, early 2018, we released SSO version 1, which allowed you to choose whether you wanted to use AWS SSO or Active Directory as a place to manage your identities. And your role-oriented permission sets, which are really definitions of roles that don't exist yet. Then you assign those to the users, and once they're assigned an account, then the users or groups have access to these roles. What that means is AWS SSO created the role structure for you. So instead of creating them manually, you have a common set of roles that apply across multiple accounts. Then you assign the right users and the right accounts to these roles. In addition to that, we added the ability to connect external apps like Salesforce, Box, Jira, and we released this out. Then we took another step with version 2. We're looking to make access management easy and give you the ability to control access to AWS and applications using whatever identity you want. Whether it's Azure AD or anything else, it shouldn't matter to us what identity you want to use. We have the standards to handle that, as we've discussed earlier. We want to know who you are, and we need to have a good, strong way to authenticate you. So AWS also supports users from Active Directory, or from an external IDP such as Okta or the AWS SSO native identity store. So you can centrally manage and assign access for users across all your accounts. Users can use single sign-on to all the AWS accounts you've granted them access to, as well as to hundreds of SAML-based SaaS applications such as Jira, Slack, ServiceNow. And this is one access control model, and you choose your identity source. So using AWS SSO is actually as easy as 4 or 5. So you choose your identity source, you define a role-oriented permission set, you assign groups, users to the permission sets in the selected accounts. And for application access, you connect cloud apps with SAML and then assign groups and users to those apps. So let's take an example here. Let's take a quick look at several deployment options with AWS SSO. So we show that AWS Managed Microsoft AD, used as a user force, your identities are in here, can be used directly with AWS SSO. AWS Managed Microsoft AD, if it's used as a resource force, would need a trust to the on-premises AD where your identities are. Or AD connector can be used to connect to the on-premise AD to get to your identities. As a reminder, AWS SSO needs to be in the AWS organization's master account, as does AD Connector or AWS Managed Microsoft AD. Active Directory users can be in any one of your accounts. And in using any of these models, you'll still see the standard AWS sign-in experience. And here we show that AWS SSO can connect to an external IDP such as Okta or Azure AD with normal SAML 2.0. As well, synchronization can be achieved by using SCIM, which is the System for Cross-Domain Identity Management. And of course, SCIM is optional, but it is recommended. And as noted in the slide, ensure to synchronize your email attributes if you're using this. Now, to offer some guidelines as you scale identity management, you want to use AWS SSO because it's simple to create and manage users with no need to set up additional infrastructure. Currently, user management is through AWS SSO console only, so it's appropriate when the scale of users is quite small. Using Active Directory, many customers come in from data centers where they're using Active Directory to manage their users. They're often moving AD-dependent applications to the cloud, and they extend AD into AWS. Or they don't want to set up federation services like ADFS. So this is when you use Active Directory. You can use an existing IDP if you have a federation infrastructure that exists to access SaaS apps. And if you want to simplify and federate just once and to access all AWS accounts and applications. So AWS SSO lets you pick what's best depending on where you're beginning your identity journey. So let's recap AWS SSO. It supports open standards, SAML 2.0 and SCIM. You can create users inside of AWS SSO, connect them from Active Directory or SAML 2.0 IDP. AWS SSO configures and maintains all the necessary permissions for your accounts automatically. No additional setup is required in the individual accounts, and this is via permission sets. And AWS SSO is the source of truth for metadata, users, groups, group memberships, if you can edit them in AWS SSO. Otherwise, the identity source is the source of truth, and AWS SSO only holds a copy of what's synced in from the identity source. So we spent considerable time on identity management. For completeness, let's spend a little time to talk about resource management. So some customers have as many as hundreds of AWS accounts, thousands of instances, billions of objects, trillions of DynamoDB database, thousands of workloads. Your complexity may not be as high, but the point is that scale is increasing and moving to the right. This means that we need to have a more scalable way of managing resources that isn't always at the individual resource level. So simplifying the complexity, we need to manage resources at scale, and we can break this down into 3 steps. Find my stuff, so for example, find everything that belongs to Project Blue. Organize my stuff, group everything, all the resources that belong to Project Blue, and then manage my stuff. Allow only Project Blue developers access to resources that are in Project Blue. Tag policies is a feature that allows you to define rules on how tags can be used on AWS resources. You can tag policies to easily adopt a standardized approach for tagging AWS resources, and you have a simple way to consistently apply tags, enforce allowed tags, audit tagged resources across your entire AWS organization. So what this means is tag policies is integrated with AWS organizations, and you can apply a tag policy to your entire organization, specific organizational units, and to individual accounts. After applying the policy, you can export a cross-account, cross-region report to easily aggregate, view, and share the data with resource owners to correct non-compliant tags. Standardized tags enable customers to confidently leverage tags for critical use cases such as cost allocation, attribute-based access control, which we'll be talking about in a moment, because you can ensure resources are tagged with the right attributes. So now let's spend a little time talking about access management, the third pillar that we were talking about since we've covered identity management and resource management. AWS provides granular controls and has provided ABAC for years, but managing this at scale can at times get complex. So wouldn't it be nicer if you can express an access control rule in more human understandable policies, like, for example, all engineers who have taken course equal to launch instances can launch new instances that are tagged as launched instances. And wouldn't it be cooler if those rules automatically scaled and adjusted as properties of your users dynamically changed? Enter attribute-based access control. This is an authorization strategy that defines permissions based on attributes. In AWS, these attributes are called tags. And tags can be attached to IAM principals, users or roles, and to AWS resources. You can create a single ABAC policy or a small set of policy for your IAM principals. Now, note on the slide, there was only one policy there versus all the policies role-based access control had. So these ABAC policies can be designed to allow operations when the principal's tag matches the resource tag. It's helpful in environments that are growing rapidly and helps with situations where policy management becomes cumbersome. So if the tag on the principal matches the tag on the resource, allow, otherwise deny. So some of the advantage that ABAC provides over RBAC is ABAC permissions scale with innovation. So updating existing policies is no longer necessary to allow access to new resources. Therefore, ABAC requires fewer policies. Teams can change and grow more quickly because permissions for new resources are automatically granted based on the attributes of the user. And granular permissions are possible using ABAC. With RBAC, you have to write a policy that allows access to only specific resources. ABAC, you can allow actions on all resources, but only if the resource tag matches the principal tag, or the principal's tag. Therefore, ABAC enables scaling your authorization strategy by granting access to groups of resources as specified by tags, opposed to managing long lists of individual resources. So, in other words, ABAC can be used to simplify permission management at scale. Administrators can create a reusable policy that applies permissions based on the attributes of the IAM principal, such as tags. Now, this was a big step, but it only worked if your user attributes were stored in AWS. And as we know, many customers manage identities and their attributes in another source and use federation to manage AWS access for their users. Now, with session tags, you can pass user attributes in the AWS session when your users federate into AWS using standards-based SAML. That is, you can use attributes defined in the external identity system as part of the attribute-based access control decision within AWS. Where the principals are assigned to explicit roles, we move the tag from the role to the principal. And these attributes you pass in are called session tags. And these are temporary tags and valid only for the duration of the federated session. The administrator of the external identity system, they manage and define the user attributes to pass in during federation. So when principals are tagged, we have dynamic policies, that is reducing the policy per role. When session tags are used, we have dynamic roles, and now we have reduced the number of roles that are used. Summarizing, session tags pass in user attributes via SAML-based identity federation and make use of them in ABAC decisions within AWS and have them logged in CloudTrail audit logs. This will work with any SAML-compliant IDP. In addition, the following partners listed have tested this confirms well with their solution. So ABAC with session tags makes it simpler to understand the access you're granting. But how do you know you're doing it right? How do you have the confidence that you're not granting too much access? So customers tell us they desire to grant their employees least privilege, which is the right access to the right things at the right time to do their job, but nothing more. But how do you know you're achieving least privilege over time? Typically, having to widen permissions during development, but how do you know you can safely shrink permissions as you're moving to production? For this, we provide last accessed information, such as last accessed and role last used timestamps to refine your policies and to allow access only to the services and actions that your entities use. So you can easily remove the unused permissions with confidence, as you can see highlighted on the screen and circled with the days that are circled. Access Analyzer, a feature of IAM that continuously monitors and analyzes access control policies to help teams centrally identify resources accessible from outside an account. It analyzes policies from S3 buckets, KMS keys, SQS queues, IAM roles, and Lambda functions. All possible access paths are verified by mathematical proof, and this is done via cognitive science called automatic reasoning. It's fast, and it quickly analyzes thousands of resource policies in just seconds. It's comprehensive, and it uses mathematics to comprehensively assess all access paths. It is not using historical access data to make predictions. This is the first service powered by automatic reasoning, and it's now available to our builders everywhere. And it's available to you free from within the IAM console. Also, you find it via S3 console and Security Hub. And you can use Access Analyzer to centrally analyze access across your entire AWS organization. So what are our takeaways from this presentation? You want to make sure you use AWS organizations to centrally control access, manage billing, and share resources across all your accounts. You want to manage user access centrally via AWS SSO. Tagging is not just for billing anymore. Use tag policies and try attribute-based access control, and remember about session tags. Use IAM Access Analyzer and role last used to reduce unnecessary permissions. You want to support building your own community of identity professionals as well. And to learn more, you can go up to aws.amazon.com, WAC identity. You can do IAM, single sign-on directory service, also organizations, things like that. And also, if you want to learn more about security with the AWS Training and Certification Center, the URL is right there. And I'd like to say thank you very much. Again, my name is Mark Shalkevich, and I hope you enjoyed the presentation.